Hello, Christina. Sorry for my late reply. Since I'm the TA for this term, so I have to mark the midterm by today. So I just finished my work 1 hour ago, I think 1 to 2 hours ago, and I did a quick programming for my 3D reconstruction program to make it a GUI version. Although this GUI a little bit simple, but I think it will make my program more intuitive. So here is the input directory and here is the output directory. If I click the input directory, I can choose the folder that contains the images, and then I can also choose which folder I want to output the final result. So now I select these two folders and I begin the reconstruction by clicking this button. And so I want to show you first this test2 file. It's original empty and this folder was just added by the program. And this reconstruction folder, it contains the images I took a lot long ago, and it's just my study room. It's quite messy, but the point is I want to take multiple images for this scene, and I want to reconstruct the 3D structure for this scene. And you can see I just randomly taking photos for this scene. There are around 12 photos. So yeah, that's the input. And because the output file is in the PRY format, I will use another software, which is this one called the MeshLab, to view all the files. So we can check this folder. You see here there's a new folder which contains the results of the reconstruction. It's still running, and because it took a couple minutes to finish the whole process, but now it's the first step. I can show you what this look like. On this, you can see here just some points of the images, and these green points represent the camera position. So basically, this program first used these points to compute the position of the camera. So each of this green point is the camera position, and by finding these positions, then they can find more dense points across different images. And these points, why they only choose these few points here, is because these points are somewhat special. They're usually corners in the images, so that they can be easily tracked across different images. So by using these points, this program can know the same point, the position of the same point across different images, so that they can use this information to calculate the camera position. So this is the second step. Before that, they also need to compute the features, but I won't get into that. I think for now the dense point should be here. No, not yet. I can see it's 70%. I will pause the video a little bit. Okay, now the third step is finished, and we can see here there is one more file here, and this is just the newly added file by the program. And we can see that by computing the camera positions, now we can compute more and more points of the images. So this, if we look at it from a little further, then we will feel that it's the 3D reconstructed model. But actually, if we look closer, they are just many small points in the images. So this is what the programmer call point cloud. So they are just points, and each point they there is the three-dimensional vector associated with it. So it's just x, y, and z of each point, and you can see there are many points for this scene. And surprisingly, they are quite accurate. So I just take multiple images of this scene, and this algorithm can show so many details of this scene. Yeah, so I just scroll around the scene so that you can look more clear what is going on. Yeah, so that's another step, and I will pause a little bit for the next step to finish. So now we get the new one. This step is computing the surface which connects all the points. So from here we can see this program is not perfect in the sense that it sometimes don't calculate well how the surface should be. If we take a closer look, what it is really doing is it computes the small triangles that can connect all the points here. So you can see they are just triangles, just different triangles, different in different sizes. And by using these connecting triangles, they can get the real shape of the image. In this time, this doesn't work very well, and there are some cases that they can work really realistic, but in here they are just I think it's because this image contains many textures, so it's hard to compute this surface. So this is the second last step of this program, and I will pause it a little bit for the last one. I think it's not, oh yeah, it's here. So this is the last one. So it maps the color back to the model, and it computes, so it smooths a little bit of the texture of the surfaces, and so it looks better than the model for the last step. But still, we can see here there's still um, some shapes that are not expected. Anyway, I think overall this program is doing a pretty good job on constructing this scene of my study room. So yeah, so here is the program that I have done. So I want to say that this program is quite complicated in terms of both programming and mathematics. So this work is actually very mathematical oriented, and it contains lots of optimization problems.